Hello and welcome to today's webinar. My name is Zhao Li. You can call me Li or Cindy. Will be today's MC. I'm happy to host this webinar. So today's webinar is about Xylem IFL sensor. IFL is an ultrasonic interface level measurement sensor. We will be sharing the benefits of measuring sludge level, how IFO works compared to the traditional method, and its advantages. Very exciting. We are also going to share 5 to 6 interesting proven results from China, Japan, Korea, and Denmark. Can we go to the next slide? Yeah. Webinar will be shared in a structured manner, as you can see here, the overall agenda. And then this webinar will be recorded. For in case that you miss anything, we'll send the recording to you to capture the things that you have missed. And throughout the webinar, if you have any questions, please feel free to type in the chat box your questions. We'll be very happy to answer you at the end of the webinar. And in between, we will have the interactive polls throughout the webinar to keep things engaging and interactive. To make sure that you will participate and share your thoughts and anything that you would like to ask. Can we go to the next slide? Let me also introduce our speakers. Okay, myself, at the very right-hand side, I'm Cindy. I've been joining Xylem a year ago as a product director for Asia, Australia, Middle East, and Africa. I'm happy to share this webinar with you. And today we have Dr. Tao Su, the leading presenter today. He has been in the industries for more than 15 years and is our leading marketing development for the instrumentations, especially process instrumentations. And he will be sharing his knowledge, insight, and experience on IFL and a lot of interesting case study that he himself has experienced. Middle one, we have our Nitin from Australia. He has more than 25 experience in process instruments. He will also share a lot of interesting case studies and his experience. And we have Michael, our marketing support over here. And we also have a background. We have myself, and Gil from Germany may dive in as well at the end of the session to answer the questions. Well, once again, thank you so much for joining us today. Let's get started. I'll hand over to you.
Okay, thanks, Lee, and thanks everyone to join this webinar. We are very happy you have time to with us. I want to say just after COVID-19, I think most of the country has opened. I think our mood and will be changed to different from the before. So I believe all of you are doing well, but today we're really very glad to have the chance to introduce our WTW sludge measurement solution. I will show this slide again. Actually, I want to introduce sludge measurement by 4 parts. Firstly, why we have to measure sludge level. Secondly, what is our Xylem solution on sludge measurement? Thirdly, we'll detailedly talk about what is IFL sensor. And lastly, we'll talk about some real application case. So please follow me. Let's start my presentation. So firstly, the background why we have to measure sludge level. It's really a very normal and critical questions. Actually, as we all know, biological wastewater treatment is the most widely used process across the world due to its high efficiency and lower cost. As known, the foundation of the biological treatment is the utilization of microorganisms to metabolize organic matters. The organic matter will be transformed into new microorganisms. Actually, this we call it activity sludge. This activity sludge will be produced every day if we do not remove them. the plant will become overrun with sludge, ultimately leading to the deterioration of the treatment process. Therefore, the continuous management of the activity sludge is essential for the proper functioning of a wastewater treatment plant. So we will have the question where we should check the sludge level. So you can see in this slide, actually, the three positions will need to be checked for the sludge measurement. Firstly, we can see the pre-sedimentation tank. It's before the raw wastewater coming to the plant, it be checked. The second one is the post-sedimentation tank, in the middle one, biological tank. And lastly will be checked in the sludge thickener tank. So actually, the accurate sludge measurement is not only essential, we can see critical for regular wastewater treatment plant operation, but it also offers many advantages. Firstly, please, we can see the right side in the aeration tank. The energy saving can be realized by controlling the appropriate sludge volume recycled, thus avoid the waste of energy in the aeration tank. Secondly, you can see the left side, the cost saving can be achieved by controlling the appropriate amount of precipitant chemical dosing in the sludge thickener. Lastly, in most of the wastewater treatment plants, the biogas can be produced. So the electricity efficiency can be achieved by controlling the appropriate amount of sludge pumped to the digester. So it can improving biogas electricity transformation. So it's really so many advantages to control the sludge level. So next I will let Li to handle this poll question.
Yes. Just to be more interactive, we are going to launch a small poll questions to understand. So the first one, what method are you using to measure sludge level in your process? Okay, I will launch the poll, then you can click, all right? Let's do it. The first one is using the sludge judge, using portable sludge meter, like TSS, optical meter, or using radar sensor, or using ultrasonic sensor.
Yes, I can see the result. Yeah, thanks, Li. Yeah, so let me, I think our audience has just seen this result. It's a very interesting result, actually. We can see 38% of the audience select using ultrasonic sensor, and 38%, sorry, Li, you will explain or me, sorry. It's okay, yeah, actually, yeah. And also 38% of our audience using the portable sludge meter is really easy using. So yeah, I can expect most of the customers do use this. But the very interesting result is still 24% of our customers use the sludge judge. The very interesting result. Thanks for the joining this question answer. Yeah, so I think we can go to the next slide. I will stop. Yeah, okay.
Sure, let's continue.
Yeah. Okay, thanks, Li. Yeah. Okay, so I just see the result, a very interesting result we got. Actually, still 24% of customers use the sludge judge. Yeah, I agree. Sludge judge is really a very easy using and convenient method. And I think because I based in Japan, I know in Japan still around 10 or 20% customers still use this method. This method, as you can see, the figure showing the sludge judge working on the sludge level measurement. It's how to say, but I should say frankly, this method has three disadvantages because of the this measurement principle. Firstly, we can see you have to let a special staff to do this work every day or like that. It will really sometimes troublesome. Secondly, due to the human error, different people sometimes will have different readings. And lastly, we can see this measurement actually is highly affected by the sunlight. So even the same person sometimes gets a different result. So if we use this method to control our sludge pump, it will be not efficient and sometimes make some trouble. So that's also my objective of this today's presentation. I want to introduce our Xylem solution. So let's go to the next slide. Yeah, we want to just introduce Xylem WTW sludge measurement sensor with it interface level measurement sensor, or we can just simply say IFL sensor. Actually, this sensor has several features. Let me share with you. Firstly, how can I say it has intelligent signal processing system, so can ensure your result is reliable. Secondly, it's very easy to use and easy to go. No need any calibration. Thirdly, it's contact-free and maintenance-free of the clean system, so makes the maintenance very easier. So lastly, the echo profile can be showed in the monitor in the real-time base, so it will make the customer to check this sludge level in a real time. So we can see next we will just see something about the principle. Actually, as you have known, Li has introduced something for the sensor. The IF sensor is based on the ultrasonic technology. As you can see in the figure showed, the ultrasonic waves are reflected by the layer. The layer can be sludge blanket or bottom of the tank. So then the ultrasonic wave will receive it again. So based on the reflection interval, the sludge level can be calculated or determined. So for the next one, we want to just introduce our advantage of IFL sensor. Firstly, I have said it has the intelligence signal processing system. So this system can rule out the undesired signals caused by floating sludge, obstacles, or moving skimmers. So it can help you get the reliable and correct sludge measurement level. So we also have some comparison with our competitor sensor. You can see this figure showed our IFL sensor is a blue line, but our competitor sensor is a green line. You can see our competitor sensor is highly affected by the obstacles or some moving skimmer. So displayed unstable or fluctuated result. This result will definitely affect the correct control of sludge pump. But it's very interesting. Our IF sensor is really very stable and give a very reliable result as the blue line showed. So this figure just demonstrates our intelligence process system is really can ensure our reliable data. So secondly, want to just say it's very easy to use because no any calibration. You can just set up it and use it immediately. And next we want to see it's a contact-free and maintenance-free sensor. They have a special scriber. The black one shows this scriber is really very convenient for the customer, so no need any maintenance for the solid sensor. As I think some customer have experience to clean the sensor frequently. So if you use IF sensor, no need such work can be done. It can you can just setting up in your monitor. It can clean the sensor based on your based on our time interval. And you can see the red figure also showed even in the very dirty water, so many algae cannot any infection for this sensor part. So really very good sensor. And lastly, you can check the echo profile in the monitor. You can see many details information in the monitor, so can help the customer check the sludge level in the real time. So next poll question. So Li, please help this.
Yes, let me launch the second one. Okay, what's your key issues in sludge level monitoring? Okay, let's get started. Okay. Back, launch the second one. All right. Yeah. So the first one, okay, inaccurate measurement, difficult to set up and maintenance. The third one, short life, frequent breakdown. All right. So multi choices. Okay, let me show the result. Okay, can you make a guess? Okay, if you can see it.
I think maybe maintenance, but let's see the result. Thanks, Li. Yeah.
Inaccurate measurement. Okay, so inaccurate, this is the first one. And the second one is actually expensive. Okay.
Oh, yeah, cost.
Third, yeah. The second one is difficult to set up and maintained. Okay. The fourth one is short life, frequent breakdown. All right. Yeah, thank you so much for the answer. I think we get to know the pain points in what everybody experiencing. Let's continue. Okay, let me stop sharing and Tao, please take over.
Okay, thanks, Li. It's very thanks so much for the answer. Actually, the accurate of the sensor really very important issue for us. But please trust our product. We can give you the reliable answer, reliable date. For the cost, I think yeah, we will try our best to give the best price if we can. Yeah. Okay. So let's go to next one. For some successful stories by using our IFL sensor. You can see this one is this application is from a drinking water plant in Chongqing city of China. This plant, they use a chemical precipitant chemical for sediment of the sludge. They call it PAC, is polyaluminum chloride. They use PAC to remove suspended solid in the sedimentation tanks. The problem is previously the customer dosed the PAC just based on the staff's experience. So you know the experienced staff yes can do this work well, but sometimes the amount of PAC cannot be dosing accurately, and also the dosing is manually and troublesome. We can see we can imagine, and also the customer want to make this dosing system much more automatic and accurate. So we have recommend our IFL sensor. So let's see the second slide to see sorry. Yeah, no second slide. So sorry. Yeah. So actually, by this recommendation, the customer has used our IFL sensor to get accurate data and also automatically environment. Very happy for our solution. So secondly, let me see another application stories also from China. This application is from a wastewater treatment plant in Beijing. That the customer is previously to use the TSS portable meter to measure the sludge level. I think for the poll question one, still 38% of our audience have selected this method. This method actually is really convenient because and also mostly used in many wastewater treatment plant. But you know this matter problem is you have to calibrate the sensor frequently, and also the staff how to use it to measure the level in this plant, how to measure the sludge level twice a day. So it's sometimes it's troublesome. So our solution still use our IFL sensor. So let's see the result. So when after they used our IFL sensor, the result is make this work much easier. If you can see although some Chinese, but I have show some English. You can see the red figure. You show the IFL sensor data is the blue dot, but the customer's previous old method, the TSS electrode, this red dot, we can see the result is perfectly equally. So also we can see the relative value is very, very high. So the customer actually is very satisfied our sensor because we help them to reduce the labor cost and also can make this system automatically. So let's see another application case. This application case is, I guess some people, some customers know this. It's a very special application in the wastewater treatment plant. As known, in the big wastewater treatment plant, the rotation scrubber bridge is mostly used. But this rotation scrubber bridge sometimes is difficult to find a good position for setup of a sludge level sensor. If we set the sensor in the central part, sometimes the cable cannot connect to the PLC. But if we set in the edge, on the edge of the tank, it is not a good position. So for solve the customer problem, we recommend our IFL radio wireless collection. It has solved all the problems. The perfect position in the middle of the bridge can be used, and also the wireless connection can avoid to using the cable connection for the PLC. We also have a slide to show how it worked. It's by this, you can see this. We just use a master controller. By the radio wireless connection, we can control this 4 sliver controller for the sludge level measurement. So the result is satisfied by the customer. This figure shows the customer use our IFL sensor to control the pump. When the sludge level gets this value, okay, the pump will start it. When it gets that value, will start by this method, and also by the idle position of the sensor setting, makes this work much easier, and the pump worked much efficiently. So also this similar application has been used in Japan and South Korea. We can see this is South Korea Su1 wastewater treatment plant, and this is Japan wastewater treatment plant. And lastly, we want to show another case. It's really very special because it's not a wastewater treatment plant applications. It's our coal washing plant in Shanxi of China. The coal particles shown in the left figure will be set down by the gravity. So the level of the coal level of the coal should have to be checked by every hour by a staff. So it's really very tough, especially the night. So they use our IFL sensor, check the coal level, and the result is really very satisfied by the customer. You can see the data showed. This is the blue line is IFL's value, and the orange dot is the manual measurement or the previous old method by the customer. They got very good data. So now they have used our sensor for the measurement of the core level. So we can see our IFL sensor not only used in the wastewater treatment plant, but also can be used some other settlement tank. So like this one. So that's all. So I think the next one will be, I will let Li to handle this.
Yes, actually, this is the end of the case study sharing. We have received some interesting questions. So, the Q&A, please feel free to type in if you have any question. But before we go in that, we have one last poll questions. Would you like our product specialist to contact you with more information? So in case you would like to have a deep dive understanding, or you would like to us to quote you for a particular job or anything else, so would you like us to contact you? Okay, let me start with the poll. A moment. I see most of people clicked yes. Okay. Yeah, we could even have the one-to-one discussion. We could also get a chance to visit your plant if you have any question, if we have troubles for installation, maintenance. Even it is not our product, I think, because we have been in the industry for long enough, our service engineer and our sales engineer, our dealers are all over the country. They could actually go down to help you, to take a look at what trouble you have and think that we can help you, even though it might not be our products. Okay. But if it is our product, of course, that's our responsibility to help you. Okay. So majority of people select yes. Let me close off the poll, then we could answer the questions. Okay. So that's the question session. We have leave about half an hour, long enough for any questions. So let me read the questions one by one. Okay. So so Dr. Tao and Nitin, so as you mentioned the accuracy, can you tell us what's the accuracy of your IFL sensor? How do you know like your IFL sensor accuracy is high enough? Can you answer this question?
Yeah, I can take that, Dr. Tao. Is that okay?
Yeah, please. Yeah.
Yeah, thank you. We have tried our IFL sensor in a number of applications, and generally we find that our sensor is quite accurate. The published accuracy is 0.1% of the measured value, and we have had really good results to confirm that this is quite correct. So the accuracy is 0.1% of the measured value. The resolution will be much better. It will be 0.01% of the value, but the accuracy is 0.1%.
Thank you. And what's the measurement range? Like from which meter to which meter?
Okay, the measurement range is from 0.4 meters. So that's from 40 centimeters. It can go down to all the way to 15 meters. And the reason I say it starts from 0.4 meters is because being an ultrasonic sensor, there is a blanking distance below the sensor itself, and that is 40 centimeters for the sludge level sensor. So that's why we start from 0.4 meters right up to 15 meters sludge depth. So in my experience, looking at all the clarifiers, probably 15 meters is well more than sufficient. Most of the clarifiers are probably about 5 meters or 6 meters in depth, but there are some that are even deeper than that. So 15 meters easily covers that range.
Okay, sounds great. Yeah, the accuracy, the resolution, as well as the measurement range is the top of the class. I think we are the best, I would say, in the level measurement. All right. And so the second question will be, can you elaborate again? What's the main advantages of your level sensor?
What is sorry, repeat that, please.
The main advantages.
Okay, yeah. Oh, the main advantages, there's quite a number of them. Going back to the poll question, I think out of the four possible answers, most of the customers, most of the people on this webinar came up with well, there was maintenance and then inaccuracy. Probably inaccuracy was the biggest one, and then the maintenance, and then the high cost as well. So the advantages that we have in regard to the IFL sensor probably covers all of these. So it's proved itself a number of times, and the accuracy has been very, very good compared to all the other methods that we have seen in the market. But apart from that, the maintenance itself is quite low, and I can say that from experience here in Australia. And then the expense, yeah, well, that depends on what the customer was previously using. But when we compare it with the rest of the sensors in the market, we are pretty well placed. But the biggest advantage, I would say, two advantages I would say would be, one is the accuracy, and the second one is the ease of maintenance. apart from that, of course, it's quite easy and simple and straightforward to set up, install and set up. And if you do require any help from us in regard to installation and setup, of course, yeah, we are always there available to give you a hand, or we can do it all. We can install it, we can set it up for you depending on your clarifier depth and so on. And that is the big advantage that we have. In fact, in most applications, particularly if it is a secondary clarifier, the only things that we would have to enter to get the measurement started is or are two things. One is the clarifier depth itself, and the second one is how much is the sensor immersed into the water. So as long as we put these two values correctly, the accuracy is maintained, and it's very easy and straightforward.
Thank you, Nitin. Yeah, thank you, Nitin. Have a few more questions now, more and more now. So the another question about the IFL sensor is how good it is compared to the radar-based sludge sensor or detector.
Yeah. Okay. Well, one of the advantages of the radar sensors, everyone says, is it can see through the foam and any material on the sensor on the surface of the water. The really nice thing about the sensor that we have, the ultrasonic sensor, is it is not sitting above the water. It actually sits immersed into the water. So anything that happens above the water is not going to affect it. That's the reason why it compares very, very well with the radar sensor as well. Yeah. So this sensor is actually sitting inside the water.
Yes. So there's thank you so much. Now we have a good understanding of the difference. And there's another things that the audience asked. So your the sensor, right? Do you have any problem of measuring the measuring the level with respect to the density of the sludge and the water content? You know, will the specific gravity of the sludge make a difference to the sensor in measurement? And the second question is, how about the usage of this sensor in effluent sludge? Okay, from industry like, you know, like bulky jugs or tannery sludges, right? Not just the municipal wastewater, but other industries.
Yeah. Okay, I'll answer the first question. That is in regard to the specific gravity or the density of the sludge itself. What our sludge level sensor actually measures is where the solid sludge is, or where the sludge is more dense. So if you look at the graph on the screen of the controller, the echograph on the screen of the controller, it actually shows where exactly the soft sludge starts and how it progresses into a solid sludge. So based on the density of the sludge, it actually points out where actually it is the most dense. So that is where it chooses the actual sludge level. Okay, so you can easily see from soft or fluffy sludge right up to very dense sludge. So if the specific gravity or the density of the sludge is increasing, that is very easily picked up by the sensor, and that is very clearly shown. In fact, for the measurement of the solid sludge, that is the point we choose actually, where if you look at the graph, where the curve is actually at the most gradient, highest gradient, that is the point that we choose to measure the sludge level. And the second question, in terms of other applications apart from municipal applications, well, to a large extent, we have seen these sensors being used in municipal applications. So most of the time in secondary clarifiers, but they can be used in primary clarifiers as well as in drinking water treatment plants and so on. If it is an industrial site, and as long as we know that the sludge is settling, then it can be measured. So that's my simple answer to this. If the sludge is not settling, then it does pick up, it does show where the sludge is and how soft it is, as in it shows the soft sludge. But if you really want where the sludge is solid and where it can be measured, then the sludge needs to be settled sludge. So even if it is industrial, as long as it is settled sludge, then that can be measured.
Okay, yeah, thank you so much. And there's another question, things we also mentioned in the mining. So the question is that, our sludge level are supposed to also measure other applications such in mining, so can you confirm that? And is there any special care that need to taking care for this?
I haven't come across a particular application in mining in Australia, particularly where we have used this sensor. We do have one application in mining, but that was also in a wastewater treatment plant. But apart from that, if it is any other mining sludge other than wastewater, other than municipal waste, other than sewage, then as long as it'll settle down, then that can be measured. That's my answer. But if you have a specific application, please feel free to contact us. You can contact Dr. Tao with details of your application, so we can actually visit your site, understand the application better, and then where required, we can do a trial as well, and make sure that it actually works for you.
Right, thank you. Yeah, that answers, yes. We're happy to solve customer problems, so just reach out to us. And we have another interesting question. So regarding IFL 700, right, so what happens if that sensor immersion depth is more than 0.1 meter?
Yeah, that's a really nice question, because probably when we say immersion, it can be immersed at various applications. In various applications, it can be immersed to various depths, right? So that's a really nice question. Normally, we immerse the sensor about 10 centimeters inside the water. So there is a mark on the sensor itself. I don't know if that picture is shown in one of this presentation, but apart from that, on the sensor itself, there is a very clear mark which points out to 10 centimeters, and normally it is immersed to that depth. However, if you have to immerse it even more, say you have to immerse it to 0.5 meters or even more, 1 meter or something like that, then that can be done as well. The sensor is capable of good quality measurements as right up to an immersion depth of 3 meters. So it can go down to 3 meters in immersion. However, when we set up the sensor, we have to tell the controller what is the depth of immersion. So as I said earlier, there's only two things that we need to answer in most of the cases, particularly in secondary clarifiers. One is the depth of the clarifier. So when I say depth, from the bottom of the clarifier up to the water level there, so that is one thing we have to specify. And the second thing is how much is the depth of immersion of the sensor. So normally it is 10 centimeters, but if you immerse it a bit more, doesn't matter. You just have to ensure that you have put in the correct value in the controller.
Okay, thank you. And the second one is any dead zone detected by the IFL 700 sensor?
Sorry, could you repeat that, please?
Is there any dead zone detected by IFL 700 sensor?
Depth, you mean?
Dead.
That zone,
DEAD, dead zone. Dead.
Oh, but yeah, that dead zone, that is already there. So 40 centimeters is the dead zone or the blank zone. But that is taken into account in the calculation automatically.
Okay. And third one, can the transmitter able to back calculate and display the the height of a sludge rather than the depths, but the height?
Yes, absolutely. So when we set it up, you can actually choose whether you want to see the height of the sludge from the bottom of the tank, or whether you want to see the depth of the sludge from the water level inside. So if the preference is to see the height of the sludge from the bottom of the tank, yes, definitely that can be seen as well. Yeah, so it's up to you what you want to see. And in most cases, customers actually want to choose want to see the height of the sludge from the bottom of the tank. So that can be set up definitely.
Sure. Okay. And also, do you have actually a variety of sensors that can measure different density or level of sludge? Is it necessary? Or one sensor is able to adapt to a very wide range of application?
Yeah, if the requirement is to measure sludge level, then this sensor can handle sludges of various how should I say, various suspended solids concentration. So that doesn't matter. As long as it is settling, then it can measure that. If it is not settling, it will show you where in the graph, it will show you where the sludge is soft. But if you really need a really good reading, then it needs to be settled. Yeah. Solid sludge. Yeah. Yeah.
Sure. So because it's actually the ultrasonic to detect.
Correct. Yes,
not necessary
absolutely.
to have.
Yes,
So it's a very wide range of the applications, different densities.
Yes, absolutely. Yeah.
And by the way, how often do we need to clean our sensors? I think we have the automated cleaning systems. Do we still need to taking out and clean it frequently?
Look, the automatic cleaning system is basically a scraper. So it's not a wiper that actually touches the sensor surface. There is a very thin gap between the sensor surface and the scraper itself. So the scraper is essentially to get rid of two things. One, things like algae and so on. But apart from that, it also helps to get rid of air bubbles. So when there's air bubbles, it can cause interference. So the scraper actually gets rid of the air bubbles. That said, the sensor is pretty clean, generally speaking, but we do say that you have to pull it out and have a look at it once in a while, maybe once a month or a couple of months. Have a look. If it looks clean, that's fine. But if it doesn't look clean enough, just give it a wipe, just with a soft cloth or something, and put it back in the water. That's all that you need to do.
Oh, I see. Yeah. So people are asking, so what's the material of the sensor? Are your sensors also capable measuring in acidic sludge or alkaline sludge as well?
Yeah, okay, that's a good question. The sensor itself is made of stainless steel, 316 stainless steel. But the material at the bottom of the sensor, I have to double check what exactly it is. I can't remember it, but we can check that up and come back to you. So the sensor housing itself is stainless steel, but the bottom, I'm not sure what exactly it could be, whether it's PEEK. I'm not sure. We have to confirm that to you.
Sure. And the other question is, what's the reason that your sensor is immersed in the process? Can't it be contact free? Will that be better?
Well, this is an ultrasonic sensor, and when it is above the water, it can be affected by what happens above the water. So if there is any floating material, or if there is anything, if there is foam and froth, then they can interfere with the measurement signal, because the ultrasonic signal can measure that rather than the actual bottom of the tank. So that's the reason we actually immerse the sensor into the water, and that has the same benefits as any radar or any other sensor. So it actually sits inside the water.
I see. As you mentioned, the sensor is immersed and there's a bridge if it is moving. How this is working out when the bridge is moving, but your sensor is in position?
Yeah, okay. Yeah, that's another good question, actually. I'm glad someone asked that question. So generally in clarifiers, we find two types of skimmers. So there is a bridge, and there are some clarifiers where the skimmer actually rotates along with the bridge. And the second one is where the skimmer rotates separately to the bridge itself. So where the skimmer rotates along with the bridge, there's no issue at all because the sensor is mounted off the bridge itself. So as the bridge moves, the sensor moves along with that. That doesn't affect our measurement because we already have set up a stabilization time or an adjustment time there. So that is already there. However, in the second option where the skimmer moves separately to the bridge, then that skimmer can run against the sensor. So for that, we have a special mounting arrangement where there is a deflector which deflects the sensor as the skimmer comes into contact. And as soon as the skimmer passes, then it's back into position and it starts measuring again. So we have both types of arrangements, just depending on your application.
I see, I see. So basically, there is no problem having the bridge moving. So the bridge is coming, and this devil is going to deflect. Right?
Correct.
It's going to push forward, and when the bridge is over, it come back.
That's correct. Yeah, absolutely. Yeah, you described it very well, Zhao Li. Yeah.
Yeah.
So but that's the second option. The first option, it rotates along with the bridge, so there's no issue there.
Sure, I see a lot of benefits of this, so there's no interference or no automation, some things that need to set up. If the one that cannot move, that means you have to coordinate the bridge with the sensor coming up, right? So the coordination have to be programmed. But for us, it doesn't matter because you can just push and move and sensor come back, or otherwise moving together with the bridge.
Yeah, exactly. Yeah, I mean, we have I've come across an application in Australia where the customer was using sensors which was basically an optical TSS sensor, and it was going up and down every time, and the cable used to take it down, and then it would come up. It's like a yo-yo system. And they ran into so many issues. In fact, all the four possible answers that you had for why they don't like, what are the issues that you have with sludge level sensors, all four were seen with them. So one was the short life, the high maintenance, the inaccurate measurements, and then they were pretty expensive as well. So all those things are taken off with this particular sensor. And I can say that from what I have seen in practical experience. Yeah.
Sure. And apart from that, I think we mentioned, we have also the wireless radio connection system. So
yes, that's another way. Yeah, that's another thing as well, actually. So in many clarifiers, there's very often it's very hard to run cables across to the land itself. So for that purpose, we came up with a system where we have the wireless option as well. So we could connect this sensor with a wireless module, which we supply, and then that can communicate with another module which is on the ground. It could be in the control room or it could be in a nearby point. As long as there is line of sight of a maximum of 100 meters, then that can work very well. And yeah, there's plenty of applications where it has been done as well. Yeah.
Sure. We have 5 more minutes, audience, before we close this session. And I have a few more questions that in the chat box that let me read aloud, but please type in your questions. So if we don't have time to answer today, we'll send you an email separately or call you. Okay. Yeah. So the another question is the method sludge measurement using this sensor is approved by US EPA or meets standard method. I suppose the standard method is some standards. Do you know if US EPA will have is approved?
No, I'm not sure. I mean, US EPA, from my understanding, would look at not the way it is measured in terms of in process, but probably the US EPA would be more interested in measuring the effluent in terms of what is the quality of the effluent and that is being discharged. So I'm not sure about that, whether US EPA actually needs to approve this sensor. I might
see.
refer it back to the factory and someone in the US to verify this.
Okay, yep. And also the question also asking, so you were mentioning the sludge level measurement. The benefit of that is to save energy. How would that save energy? Can you elaborate further a bit further? Like how would measuring sludge level will save energy and save the cost?
Yeah, okay. I think the question, the person asking the question is probably referring to the slide that Dr. Tao had in his presentation, where he showed, I think how much sludge is recycled from the
Yes.
clarifier itself. So when we draw the sludge into the bioreactor back from the clarifier as a return activated sludge, we need to monitor exactly how much it needs to be based on the load that is coming in, and there is a sludge timing as well. So that is probably what the questioner is asking us. So that is where instead of putting in extra sludge into the bioreactor, which means there's more air to be supplied, and then there's more treatment to be done in the bioreactor. Instead of that, we are recycling an adequate amount of sludge back into the system. Probably that is what Dr. Tao had in mind as well, but I can't guarantee that. Dr. Tao can come in and answer that question himself.
Yeah. Nitin, your answer is perfect. Yeah, actually, you have to the point is because the aeration tank actually will be the most energy-consuming tank in the whole system. Around, if we can see the world war situation, will be 50% of the energy will be consumed just in the aeration tank. Why it's highly using aeration, the electricity or energy? Because it will use the blower for the aeration. So the blower actually it will worked always or stopped by the user. Anyway, it will be consuming energy or electricity. So as I showed, actually the aeration is just for the microorganism to grow, or we can see the active sludge how to be growth. They need energy, they need aeration, they need oxygen. So if the sludge is overloaded in the aeration tank, there will be much more active sludge need the oxygen to survive or to grow. So the energy will be waste. So that's why Nitin have point. This sludge actually has been accurately calculated. So the sludge sensor can make the function to make sure the accurate sludge should be recycled. This is why it's important for the energy saving. I hope this answer is satisfied. Yeah.
Yeah, very much. Yes. It actually clarified the very important point of why we need to measure the sludge level, and it become more and more important, especially nowadays is we are talking about energy saving, carbon footprint. That's make a contribution to to our plant, to our society. That's just one step important. Have the sludge measurement. That's all about it. Yeah, automatic sludge level measurement that can solve this problem and save energy, automate, and eventually also maintenance free. So there's many benefits. I think for now it's already hit our 1 hour mark. And this one last question before I close. People asking if this is a Xylem marketing campaign. The answer is yes. So V2V is a Xylem brand, and we are running altogether about 10 webinars for process instruments for this year. And this is number 4. Okay, we are going to have another 6 coming. Every month we're going to have one, okay, except December where we have holiday. All right. So keep eyes on our website. We are posted our webinar information. So if you are interested in other instruments, for example, pH, right? For example, our UV sensor in the future, or our other flow meters, we are going to present later on. Please feel free to join us. Okay. So thank you so much for today's presentation. Thank you, Dr. Nitin, Michael, right? And thank you so much for your time to come in. I hope that you have getting something that you do not know before. And also we are happy to connect with you after the session if you need any help. All right. So that's all for today. Thank you. You have a very good day.
Thank you.
Bye-bye.
Thank you.